Hey everyone, I want to give a brief overview of how the Unity flood simulator works and just briefly describe Unity and some of its basic functions. So I start looking down here. Under the project tab in Unity, you'll see a whole bunch of different files, and this will generally just show you the file structure for the project. The important ones to look at are scenes, at least in the beginning. So scenes are just ways of kind of organizing code for related tasks. So I would almost think of these, in the gaming world, they're kind of like different levels. In the situation I'm using them for this research project, they're really more like individual programs. So the one I would like to draw everyone's attention to is this seg image collection. And you can view any of the different scenes just by double clicking on them. So I like to think of Unity as kind of like an object-oriented framework. So within this program, seg image collection, we've got all of these different objects that have different properties attached to them. And you can sort of modify and extend these sort of class objects with different scripts. And actually these objects are scripts themselves too. And you can kind of modify them in different ways to sort of suit your needs. So there's several different scripts that sort of work together to make this image generation process possible. The ones that I really want to look at first is this auto capture script. And over here, you can see some of the details of it. So this script is set up to capture 400 images over a variety of different locations. And there are actually 100 locations, and I'll show where those are declared. So this was used to generate the 40,000 image data set that is on Kaggle, and I'll link the Kaggle and the Git for this project in the comments. So I just want to briefly cover what these parameters do. So this sets the camera resolution and width. If you change these here, just make sure you also change it here by adding a new resolution. The stride, so this controls the distance between the different captures. They're the different photos taken. So basically what this is, this whole script is just going to simulate a UAV flying a raster pattern. And these are setting the distance between the images taken. This changes the frame rate or how often the images are taken. And there's kind of an interplay here that I'll get into later, but basically, if you want to make this bigger, you need to also make this bigger. And that's just because the way this is built off of Mapbox, and Mapbox is kind of slow. You need to like actually query satellite imagery and stuff. So there's kind of this spatial caching aspect where if I'm over an area, it maybe will cache satellite imagery, say within 100, 200 feet of me. So if I jump a mile away, then it has to reload all of that, and that's making network calls, which are pretty slow. And if you go too fast, then sometimes that can result in these weird things. So I'll try and show that later. That's just kind of a brief aside for now. But what these are doing are controlling the distance of the jump. And then these control how many jumps are made to the right, which in this case, right means west and up is north. So the raster pattern that's flown is actually, it goes from east to west and then moves up north, and then west to east and moves up north. And slowly in doing that, you collect 400 images total. Now, the data folder just points to where the images will be captured. So you need to be sure that when you point it to a folder, that inside of that folder, you create X and Y directories. And if you do that and hit run, what you'll see is that you'll actually start generating these images. And if I let this run for a while, we'd collect 400 images over the Tulsa location. And where the locations are defined are in this script. So the auto capture script, and at the top of the script, you can see all the parameters that I had just covered and how they're used, shown in the script. So the actual raster pattern, you could change it if you wanted. It's created here, but the locations, the 100 locations, are here. So Tulsa is the location, and then this coordinate defines the bottom left-hand corner of the raster pattern that's flown that I described earlier. So I think this is kind of the first thing that if someone wanted to maybe tweak this, change a location, so say maybe we just want to look at Houston, you could comment this out. And now you'll notice if I run it, instead of collecting images over Tulsa, I will start to collect images over Houston. So now I've got some Houston imagery. And in the Y, you can see I've got corresponding Y pairs. Now, again, this is using Mapbox to generate these segmentation masks. And that process isn't always perfect. There's kind of, it wasn't really designed to do this. There's a lot of hacking and tweaking and playing that went into making this work. So I kind of want to point out some potential issues. So for example, like I said earlier, if I turn this way up, so let's make it 500, and let's watch what happens. So you'll start to see some weird, crazy stuff, and it just doesn't look right. And that's because, again, it's having to jump so far. It needs to completely reload all the assets, and there's a lot of network overhead, and it just can't do it in the time allowed. So if you really do want to make big jumps, I suggest trying to keep these numbers fairly small. But if you did want to try and make a bigger jump, you would probably want to set this number higher. So this basically is just going to make the jumps happen very slowly. So instead of say 61, maybe we could set this to, I don't know, also 200 or something like that. So we'll set that to 200 and give this a shot and see if it works any better. And you can see now it's looking a little less confused. It's still not always perfect, but I think we're seeing some slightly better results. So maybe even slow it down even more, or we could also try just cutting this down a little bit. And really my intention in showing this is just to show some of the limitations of this. It definitely is not always perfect, and you will have to play with it, get it fully working. And again, you can see it it's struggling to load as it moves, but sometimes you'll see the tiles actually populate. So that's something to keep in mind. It's a little bit limited in how far you can render it. There are some other things you could probably do in terms of actually changing some settings in the map also to do that. So there's these things. So the extent around camera bounds, that is kind of saying cache, do the temporal or the spatial caching around where the camera is. So that basically just means if you're say over Tulsa at a certain location, it's going to just download some of the imagery right around you. And actually that can sort of be demonstrated. You can actually see that happening if you look at the scene view. I'm going to zoom out. You can see how it's sort of slowly moving around. So this is the caching. Now, if I tried to make a big jump, it wouldn't have any of that stuff that's already loaded. It would have to go way over there. So that is one thing that I wanted to point out. Another thing that I wanted to look at is the water. So if you look under the main camera object, you'll find water. So the water actually kind of follows the camera around as it moves, and that helps to generate a bunch of different flood scenarios. So the water is always a set distance below the camera, and the camera is always a set distance above the terrain. So that kind of gives you a varying view of different levels of flooding, just kind of based on the shape of the terrain. So the watercolors, again, so here are the two main colors, and I set these statically. But one thing that I think could really be helpful is to set these dynamically, maybe even create a script that can change the values of the colors sort of within a range, so you get a good range of color, not just always the sort of brownish color. And I think that could really help to make this data set actually a little bit more transferable to real life, real world data. Another thing that I'll point out just briefly is the, so under this object, the FloodSim SDK, so this script is what is actually kind of doing the control for the segmentation. So if we look at that, here you can see the actual values for the segmentation mask where they're set for the different classes. So this is the script to look in if you want to kind of tweak that. This is pretty tricky, pretty advanced, and I had to do a lot of hacking to get this to work. Maybe there's a better way, and certainly if someone finds a better way, I'd love to talk. Maybe you can submit a pull request and help me out. But yeah, for now, this is where that code lives for those who are interested in that. Let's see. Yeah, I think that's, I mean, that's pretty much it. I'd like to thank everyone for watching. And if you have any questions, just leave them in the comments and I'll try to get back to you. Thanks.